Good morning, students. Now, today is 7th May, and today we are going to solve quadratic equations with complex roots. Quadratic equation with complex roots. This is complex roots. In class 10th, you have solved quadratic equations where d was greater than equal to 0. That is, discriminant was greater than equal to 0. Discriminant is b square minus 4ac. You know all these things. If d is greater than 0, that is if it is positive, equation will have real roots. If d is 0, then equation will have equal or repeated roots. But in case d is negative, when d is negative, then you were asked to leave the question there and write that equation will have no real roots. But here in this class, we are interested in equations with no real roots because now we know about the imaginary numbers and complex numbers. So here in this class, we'll solve the equations with complex roots. Method is same, nothing is different, only iota will be attached with negative discriminant. First one is x square plus 2 is equals to 0. This is a quadratic equation. So we'll take x square as minus 2. So x is plus minus root minus 2. Now root minus 2 is actually iota root 2. So x is plus minus iota root 2. So x will have two values, iota root 2 and minus iota root 2. So in this way, we are going to find the discriminant, or if it is factorizable, then we'll factorize it. Next is x square plus x plus 1 is equals to 0. In this case, we are going to find the discriminant first. It is b square minus 4ac. 1 minus 4 into 1 into 1. A is 1, c is 1. So this is 1 minus 4. This is minus 3. So this is less than 0. It means the equation will have no real roots. So we are going to solve it because now we know about iota. So solution is x is equals to minus b plus minus root b square minus 4ac upon 2a. So this is minus 1 plus minus root minus 3 upon 2a. A is 1. So this is minus 1 plus minus root 3 iota. Root minus 3 can be written as root 3 iota. So x is minus 1 plus root 3 iota upon 2 and x is minus 1 minus root 3 iota upon 2. Next is 9x square plus 10x plus 3 is equals to 0. So d is b square minus 4ac. So this is 100 minus 4 into 9 into 3. 100 minus 108. This is minus 8. Again, discriminant is less than 0. That is, it is negative. So equation will have complex roots. X is minus b plus minus root b square minus 4ac upon 2a. So x is minus 10 plus minus root minus 8 upon 2 into 9. Root minus 8 is 2 root 2 iota. 8 is 2 root 2 iota, 2 root 2. And because this is minus root 8, so this is 2 root 2 iota. So x is minus 10 plus minus 2 root 2 iota. Taking out 2 as common factor, this is minus 5 plus minus root 2 iota upon 18. 2, this 9. So the roots are minus 5 plus root 2 iota upon 9 and x is minus 5 minus root 2 iota upon 9. So in this way, you can solve the quadratic equations with complex roots. The only thing is that you have to find the discriminant first. This equation is root 3x square minus root 2x plus 3 root 3 is equals to 0. First we will find d. This is b square minus 4ac. So minus root 2 square minus 4 into root 3 into 3 root 3. This is 2 minus 36, that is root minus 34. So x is minus b plus minus root b square minus 4ac upon 2a. So x is minus root 2 plus minus root 34 iota. So x is root 2 plus minus root 34 iota. So solution for this is the solution, root 2 plus root 34 iota and minus upon 2a, sorry, here 2a, you can take 2a here. So what is a? This is root 3, so 2 root 3. Okay, now next equation is 3x square plus 8 iota x plus 3 is equals to 0. Again we are going to find discriminant. This is 8 iota. Coefficient of x is 8 iota. So 8 iota whole square minus 4ac. So this is 64 iota square. And since iota square is minus 1, so this is minus 64 minus 36 minus 100. This is less than 0. So x is minus 8 iota plus minus root b square minus 4ac upon 2a. So minus 8 iota plus minus root minus 100 upon 6. Minus 8 iota plus minus 10 iota upon 6. So this is minus 8 iota plus 10 upon 6 and minus 8 iota minus 10 iota upon 6. So this is 10 minus 8 is 2. 2 upon 6 iota and here you will get 18 upon 6 iota minus 18 upon 6 iota. So this is 1 upon 3 iota and minus 3 iota. So in this way, first find the discriminant and then solve it. Let's take this one. 17x square plus 1 is equals to 8x. So first let's reduce it to standard form. That is ax square plus bx plus c. This is 17x square minus 8x plus 1 is equals to 0. Let's find the discriminant. This is minus 8 square minus 4ac. So 64 minus 68 is minus 4. Again less than 0. Solution is x is equals to minus 8 plus minus root b square minus 4ac. So this is 8 plus minus root minus 4. So root minus 4 is 2 iota upon 2a upon 34. So this is 8 plus minus 2 iota upon 34. Take out 2 as common factor. So the answer is x is 4 plus iota upon 17 and x is equals to 4 minus iota upon 17. So now what we are going to do is cube roots of unity. Unity means 1. Till now you know that cube root of 1 is 1. But now we will find other cube roots of unity. That is 1. Cube root of 1 is 1. But 1 will have 2 more cube roots. They are complex roots of unity. There are 2 complex roots of 1. Let's take cube root of 1 is equals to z. Now cubing both sides. So 1 is equals to z cube. 1 is equals to z cube. So now the equation is z cube minus 1 is equals to 0. Factorize this using a cube minus b cube. A cube minus b cube is a minus b into a square plus ab plus b square is equals to 0. So this equation, the product is 0. So either this part is 0 or this part is 0. When z minus 1 is 0, z is equals to 1. And this is 0 and this is now a quadratic equation. That is z square plus z plus 1 is a quadratic equation. And solution for this equation is minus 1 plus minus root 1 minus 4 upon 2. So this is now z is equals to minus 1 plus minus root 3 iota upon 2. So now we have 3 cube roots of unity. Z is equals to 1. Z is equals to minus 1 plus root 3 iota. And z is equals to minus 1 minus root 3 iota upon 2. So now you see 1 has got 3 cube roots. Till now you were knowing that 1 cube root of 1 is 1. But now you have 3 cube roots of 1. One is real and other 2 are complex. So the 3 cube roots are 1, minus 1 plus root 3 iota upon 2 and minus 1 minus root 3 iota upon 2. Now let's name them. This is the real one is 1, so no need to name it. Other one, that is minus 1 plus iota root 3 upon 2, is denoted by omega, a Greek letter omega. And minus 1 minus iota root 3 is denoted by omega square. You know, this one of the cube roots, complex roots of unity, is square of the other. So if this is omega, then this is omega square. So now 3 cube roots of omega are 1 minus 1 iota root 3 upon 2 and minus 1 minus iota upon root 3 upon 2. They are denoted as 1 omega and omega square. Now properties of cube roots of unity. First one, each complex cube root of unity is square of the other. So let's prove it. Squaring this is we are taking the first root. Minus 1 plus iota root 3 upon 2. Square it. A square plus b square minus 2ab. So we'll get 1 minus 3 minus 2 root 3. Take out upon 4. Take out 2 as common factor. So this is minus 1 minus iota root 3 upon 2. So 2 2s are 4 cancelled, and you see you got this as omega square. Minus 1 minus root 3 iota upon 2 is omega square. Now let's reciprocate. Let's take the reverse order. Let's square this one, the second root. Minus 1 minus root 3 iota upon 2. So again we are squaring it. In denominator we will have 4. This is a square plus b square minus 2ab. So this will be plus because both are minus. So squaring is, you will get this. Take out 2 as common factor. Minus 2 plus 2 root 3 iota. Take out 2 as common factor. So this is 2 2s are 4. Again you are left with minus 1 plus root 3 iota upon 2. And this is equal to omega. So very important property, that one complex root is square of the other. Second is omega cube is 1. So let's take omega cube as omega into omega square. That is, we are finding the product of two complex roots of unity. So this is a plus b into a minus b. This is a square minus b square upon 4. This is 1 minus 3 iota square. So this is 1 plus 3. 4 upon 4 is 1. So very important property is omega cube is equals to 1. Another property is that now using this we can say that omega cube minus 1 is equals to 0. Another one is 1 plus omega square is 0. 1 plus omega square is equals to 0. So let's prove this. 1 plus omega square. You see, denominator is same. So here 2, LCM 2 minus 1 plus iota root 3 minus 1 minus iota root 3. So this is cancelled. 2 minus 2 upon 2 is 0 upon 2 is 0. So sum of the 3 cube roots of unity is 0. Sum of 3 cube roots of unity is 0. And another one, the product of 3 cube roots of unity is 1. This we have already done. But again we can say that 1 into omega square is 1. The same thing, omega cube is 1. And last, not the least, that one complex root of unity is reciprocal of other. That is, omega square is 1 upon omega and omega is 1 upon omega square. So let's start with this. Omega is omega cube upon omega square and omega cube is 1. So this is 1 upon omega square. Similarly here, omega square is omega cube upon omega. This is again 1 upon omega. But children, remember one thing. This cube roots of unity is not in your syllabus. This was just for your knowledge purpose. Because in some questions in higher classes, that is in 12th, you may get this omega. So just to make aware what is omega, you should know what is omega. Omega is cube root of unity. Till now you were knowing that cube root of unity, that is cube root of 1 is 1. But now you know that there are 3 cube roots of 1, out of which 1 is real and other 2 are complex roots. 1 omega and omega square. This was only for your knowledge purpose. That's all for today. In the next class, we'll be doing polar form of a complex number. Hope you have done the trigonometry part that Burde sir has done. Otherwise, you will be in trouble if you are not knowing the trigonometry. So basic trigonometry is required here. That is angles more than 90 degree, angles in first quadrant, second quadrant, third quadrant and fourth quadrant. Only that much knowledge is required. In first quadrant, all are positive, second sine is positive, third is tan is positive, and in fourth quadrant, cos theta is positive. And I think Burde sir has done pi, in terms of pi, he has explained the angles. Okay, thank you.